Hello everyone, welcome to our pre-calculus pre-recording video. This is for lesson 3, finding intercepts from equations and understanding symmetry from graph. So intercept when the graph is given, we can find the intercept, but this lesson is if the equation is given, then how can we find out the intercepts, x and y intercepts. And understanding symmetry, and for this also we have two part, another part class we have later coming up. One part is first part is from the graph, how can we find out the symmetry. We will discuss it. Okay, first let's look at the agenda. First topic is practice homework review, then finding intercepts from an equation, understanding symmetry for the graph, then some practice math. First of all, this is the homework review. There are a couple of homeworks given, and this is a picture taken from the book. Now look at this problem. 16x squared equals to 120x minus 16y squared equals to 120x minus 225. The question is, how many x-intercepts does the graph of this equation have? How many x-intercepts this equation will have? How many y-intercepts this equation will have? And how do we know? To answer this question, there are ways to make it shortcut, but before we talk about the shortcut, look at this. To find out the x-intercept, the process is to find out the x-intercept. For finding the x-intercept, to find the x-intercept, you will have to put y equal to 0, y equal to 0 in the equation, and find then x equals to what? Then you will get the x-intercept. The reason is, there is a reason for that. The reason is, on the x-intercept means this x line. On the x line, everywhere y value is 0. That is the reason why we put y equal to 0 in the equation to find out the x-intercept. So you see, if we put y equal to 0 here, everything in the left side will become 0. And then basically, x equals to something will come. Some answer will come. And there will be only one answer. We can understand it from here. There will be only one value, one answer here. And that will be 225 divided by 120. That will be this value. Okay. And then next question is, how many y-intercepts we will have? So similarly, to find out the y-intercept, this is x side and this is y side. On the y line, everywhere on the y line, x value is 0. That's why to find out the y-intercept, we will put x equals to 0. Okay. To find out the y-intercept, we can write here also. To find out the y-intercept, we will have to put x equals to 0 in the equation, and then do the calculation to find out the answer. Now, if we put x equals to 0 here, then you see this term will become 0. Okay, this term will become 0. Then y square equals to minus 225 divided by 16, minus 225 divided by 16. Then there is a square here. For this square, when it comes to this side, then it becomes plus minus square root of this. Unfortunately, look at this. First of all, look at this. How many answers here? One positive answer, one negative answer. That means two answers. But in this math, just for this particular math or any math of this type, there is a minus within the square root, which is undefined. That's why in this case, there is no answer for our y-intercept. There is no answer for the y-intercept in this math. But normally, suppose, let's say this value is plus. Just suppose, okay? Let's say this value is plus. Then you see how many answers coming? Two answers. One is positive, 225 divided by 16. This is 225 16. It means 15 divided by 4. 15 divided by 4. Okay. So that means one answer is 15 divided by 4. If it is plus, in this math it is not. We are supposing it is plus. Then you see one is plus this, another one is minus 15 by 4. So two answers are coming if it is plus. If it is plus. In this, for this particular math, it is minus, so there will be no answer for this particular math. But let's say if it is plus in any other maths you see, then there will be two answers. Now the question here is, how do you know? How do you know? We can actually look at the power. The power is 2 for the y. So basically these two, when you transfer it in the other side, it becomes plus minus square root of something. So for plus one answer, for minus one answer. So there is chances of two answers when you have a square. But when there is no square, one answer only. Okay. Not only for square, for 2, for 4, for 6, then for this is 7. So for 8, you will have always plus minus for all even number. 2, 4, 6, 8. If the power is 2, 4, 6, 8, etc. here, then y value will be there will be two answers here. And same thing goes for the x. If you see power for the x, 2, 4, then 6, 8, 10 like that here, then there will be two answers there in the other side. For 3, 5, there is one answer because that's odd number. For odd number, there is no plus minus. So this way, without solving the math, from the concept, we can understand how many answers we are going to get. Okay. Okay, let's recap what we said so far. How many x-intercepts does the graph of this equation have? Since the power of x is 1, so we will have 1. How many y-intercepts we will have? Normally, we should have 2 y-intercepts, but since it is negative here, so there is no y-intercept because negative of square root is undefined. How do we know? We know it from the power of the x and y. So this is written here. What we said in the previous slide, we said that y value of any x-intercept is 0, and the same thing goes here, and that is the logic. To find out the x-intercept, y equal to 0 and solve for x. To find out the y-intercept, x equals to 0 and solve for y. This is the example. Okay. So if we put x equals to 0, y equals to what? Y equals to 5. Y equals to 5. If we put x equals to 0, y equals to, you can write here 5. If we put x equals to 0, then y equals to 6. Like that. Okay. So when we put x equals to 0, we will get what intercept? X-intercept or y-intercept? If we put x equals to 0, we will get y-intercept. Okay. The reason is you can look at the graph. On the x line, y value is 0. That's why you put y equal to 0 to find out what are the points on the x line. Okay. What are the points that intersect the x line? The reason is, see, suppose this point, the coordinate of this point will be something comma 0. X value will be something, suppose 2, then comma 0. So you see, any point on this line, it will be something comma 0. That's why we put y equal to 0 first, here 0, and then x equals to what? That will be our x-intercept. So this is the logic. These are the practice maths. Without plotting, finding the intercepts. We'll try to solve some maths from here in the class, during the class time. Now let's discuss symmetry. What is symmetry, first of all? What is symmetry? In a simple word, we can say symmetry and similarity is somewhat the same thing. How much it is similar? If it is exactly similar, then say suppose you have x and y or something and something. If it is same in your left and right side, that is same. Look at my face. If you draw a line through the middle of this, then you see I have one eye this side and I have another eye this side. I have one ear here, another ear here. So you see, about this line, the left and the right is basically the same thing, just the same thing. So I can say that about a vertical line, left and right side is symmetric, basically same thing, just a copy. sometimes we copy and paste in MS Word or in any other softwares wherever it is needed. Copy paste means same thing, another copy. So symmetry is also like that. Same thing, one copy this side, another copy is another side. That means it is symmetry. So we will discuss the symmetry with respect to if it is symmetric with respect to x-axis or y-axis or origin. What does it mean? See this. So you see this red, this is about the x-axis, symmetry about the x-axis. You see this red and this blue, these two curves, actually they are same. If you fold it, they will just fall one over another. If you fold it, see, this point will come here, this point will come here. If you fold it, if you fold this paper about the x-axis, if you fold it, then they will fall on one another. Okay, that's why it is x-symmetric. That's why it is x-symmetric. And notice that for x-symmetry, x value remains same, y value becomes minus. X value remains same, y value becomes minus everywhere. What does it mean? Let me show you with practical example. Suppose if this point is 3, 2, then the x symmetry of this point will be 3, what? Guess it. 3, minus 2. So this point will be 3, minus 2. So this is another way to test it. If you see all the points in this graph, x value is in this graph and in this graph, x value is matching, y value is also matching, but for y value there is a minus. Then you can say that okay, then this is x symmetry. Okay, so for x symmetry, x is same. For x symmetry, x is same. Y value becomes minus. Same number but minus. Okay, and by your eye estimation, you can just think that okay, about the x-axis I can fold it, and then if I fold it, they will fall on one another. They will exactly match. There will be no differences on the graph. Okay, it is said here. And for y-axis symmetry, now you can fold it about the y line, about the vertical line. The example that I said about the face. If you fold it, then they will fall on one another. Okay, this line, see, this is going up, this side also going up, then coming down, this is also coming down. Then all of a sudden it is going up, this side all of a sudden going up. Okay, and if you fold it now about the vertical axis, then they will match. Just like a book. If you fold a book on a vertical axis, say you have a book like this, and then you fold it basically like that, vertically. The previous one was horizontally. Horizontal means horizon. You see, this is the horizon, and vertical means like this, straight up. This is vertical, and this is horizontal. X-axis means horizontal. Y-axis means vertical. Okay, so vertical line is y-axis. And if you fold it, they will fall on one another. This is called y-axis symmetry. And for y-axis symmetry, what is same? Y value is same, and x value is also same but minus. Okay, there is a minus here. Same value but minus. Same example we can give here also. Suppose this point is, let's say this point is just 6, suppose 6, 3. Then this value will become minus 6, 3. Like this. This value will become minus 6, 3. Just x value, in the x value there will be minus, but y value is same. For origin symmetry, the graph will be corner and corner same. This corner and this corner will be same. Corner and corner will be same for the origin symmetry. Origin means this one. This point is called the origin. This point is called the origin. Okay. So for origin symmetry, corner and corner will be same. Even this is possible that this red graph is here, then the blue graph will come here. Then it will become origin symmetry. And there is, like this number, there is trick here also. And the trick, I think some of you already got it. Suppose this point is, let's say 2, 4. Then this point will be minus 2, minus 4. minus 2 comma minus 4. Same value, same number, but negative direction. Both of them is negative. This is positive, but now here both of them are negative. Okay, and this value will be something. Suppose this is, if this is 2, then let's say this is 4 comma 1. Suppose it is 4 comma 1. Then this point will become minus 4 comma minus 1. Minus 4 comma 1, same value. See, same value, same number, just negative sign before it. Then it is origin symmetry. Now let's say the graph comes here. Suppose there is a graph here. Suppose there is a graph here, something. Then what about this point? This is kind of crazy, because here, let me make it complicated. I'm just making it now a little bit complicated. Suppose some graph is like this, and then some graph is like this, somewhat comes here. Okay, now here in this box, see, in this box both is plus, then both is minus. But the problem is, why I am giving this example, see, the problem is in this box both value is not plus. This is minus 4. Suppose, I'm just supposing this, there is no scale here. Suppose this value is minus 4, since we have taken it minus 4, that's why there has to be same number. And let's say this value is 1, plus 1, since they are on the same line, that's why. Now what about these then? This is one value positive, one value negative. This is negative and this is positive. So what we will do for the reflection about the origin here? We will have to change the sign of both number. This is minus 4, so it will become plus 4. This is plus 1, so it will become minus 1. Meaning, we are actually multiplying by a minus with the both number here also. See, the rule is same. Here you multiply a minus with 2 and 4, then you get this. Here you multiply a minus with minus 4 and 1. That's why it becomes like this, since there is already a minus. That's why it becomes like this. So the rule is same. Let me summarize what I said. In this case, x value is same, y value sign will be changed for the x-axis reflection. And graphically you will understand by a flip about the x-axis, up and down, up and down. For y-axis symmetry, left and right will be same, left and right will be same. Okay, and in this case x value will be changed, sign of x value will be changed, y value same. But for origin symmetry, both x and y value will reverse, sign will be changed for both x and y value. If it is plus, it will become minus for their symmetry. And from the graph, if you want to understand, the corner and corner will be same. The corner and corner will be same here, not side by side. See, left and right is not same here. See, even up and down is also not same here. Okay, this way we can understand it. Now think about it. What kind of symmetry? These are from our natural life, from our everyday life, and there are symmetry actually in our everyday life objects also, as you will notice here. If you draw a line, what symmetry you see? Okay, if you draw a line here or draw a line here, what symmetry you see? Or if you draw a line here, what symmetry you see? Think about it. Okay, see, symmetry is not something very abstract. It is actually, we have this kind of thing in our real life, everyday life objects. Even if you look at everything of what you see in your room, everything has some symmetry. Unless this is something very special. Why? The reason is if an object is symmetric, then it looks beautiful. If an object is symmetric, then it looks beautiful. It looks nice. Okay, because symmetry balances everything. Okay, most of the thing in our home, in our room, in everyday appliance, they try to make it symmetric. Then just for artistic thing, they just put something extra. But most of that object is symmetric. If you look at your door, if you look at your, suppose if your refrigerator, somewhere you can draw a line, then you will see, oh my god, this side and that side is almost same thing basically. Okay, because this is how they manufacture it, they understand it. Okay, most of the time, most of the time. Suppose if you look at this, this is some uh, charging adapter. Let me show you. You'll see that this is, see, yeah. If I draw a vertical axis, see, this is same about the vertical axis. There is a pin in the left, pin in the right. See, vertical, vertically, and in the other side is also symmetric. There is a hole in the middle. Why they gave this hole, nobody knows. I mean, of course we know there is a reason for that, but see, they could give this hole in one corner also, but they gave it in the middle. They gave it in the middle. Not only for beauty, there are purpose also. So when it is symmetric, since they gave it in the middle, now it is symmetric. This object is symmetric. I did not choose this purposefully. Actually, I just saw this in front of me. That's why I'm just showing. Not every object, but most of the object you will see that there is some sort of symmetry. Okay, in our everyday life, because symmetry makes things beautiful and balanced. And with the symmetric object, it is usual for us to work with. Okay, this is always beautiful. If you want to be a very good designer, suppose if you want to be a fashion designer or something, uh, something, you first thing you will understand, you need to understand that how to balance, how to make things symmetric. Okay, always you have to balance your design or something like that. Anyway, let's go to the next page. So yeah, this is the thing that we said. Y value is changed here, x value is changed here, and both value is changed here, x and y. So this way also you can understand. By looking at the graph, we can understand easily, and then by looking at the value at the points, we can understand it also. Okay. And another way to understand is if the equation is given, which we will discuss in some other class. Then these are the practice maths. These are the in-class practice. We will try to solve some maths from here during the class time. And these are some practice maths, and try to solve this kind of maths just as a practice. Okay. That's all for today's class. Thank you all. Thank you very much. Have a wonderful day, and see you all in the class. Bye.